Alright, what's up guys? It's Matt back for another video for Math tutorials. Today we have a problem from my homework. This problem was a past AP Calculus BC test problem. Looks like it was the 1991 BC problem number 6. So let's see. A certain rumor spreads to a community at a rate of dy dt equals 2y times y, 1 minus y, where y is the proportion of the population that has heard the rumor at time t. What proportion of the population has heard the rumor when it's spreading the fastest? If at time t equals 0, 10% of people have heard the rumor, find y as a function of t, and at what time t is the rumor spreading the fastest? Okay, so let's tackle this one by one here. So first let's write the thing that we're dealing with, dy dt. So the change in y as t changes equals 2y, 1 minus y. Alright, so what proportion of the population has heard the rumor when it's spreading the fastest? So we're looking for the proportion of the population, which is going to be y, because y is the proportion. So we're not looking for anything to do with t right now. So we just want to know how can we make this the biggest, because this is how fast it's spreading. So we want to make dy dt the biggest, and we're asking what y makes that happen. So if we think about what y is, it's going to be, looks like a quadratic, right? Because you're going to multiply y by itself. So let's kind of graph this out here, a rough sketch. So it's going to have zeros at 0 because that's one of the factors, right? Y by itself is one of the factors. So it's going to have a 0 at 0, and it's going to have a 0 at 1 because 1 minus 1 is going to create 0, which means that parentheses is going to be 0. So it has a 0 at 0 and a 0 at, let's call this 1. So 0 and 1. So and it's going to be negative. It's going to go like this, not like this, because we could see that if we were to multiply this out, the y squared part would have the negative right here, because it would be this times this. So it would be negative y squared. So we know it's going to be like that, in that shape. So we know that the kind of highest point, I forget what they call it, to be honest with you, but it doesn't really matter. The highest point we know is going to be directly in the middle of these two, the two zeros, because that's how all parabolas work. If you can imagine a parabola, it's got its highest slash lowest point directly between two of the zeros, right? The 0 there, directly between is the lowest point. So we know that we don't actually know where it's going to be, right? Because that could be different, right? But we know that the highest point is going to be at y equals 1/2. And confusingly, this is actually the axis representing y, and then this is representing dy dt on this axis. But we know y equals 1/2 is going to be where it is the highest. So that one's easy. A, answer is y equals 1/2. All right, so now B. If at time t equals 0, 10% of people have heard the rumor, find y as a function of t. So this one is a little bit tricky. So I'm going to rewrite the thing here. dy dt equals, what was it, 2y, no, it's 1 minus y. Yeah, 1 minus y. Okay, so first thing I'm going to do is factor out a -1 from here. You don't have to do this. The only reason I'm doing this, to be completely honest with you, is because I want to make it look more like the form I had when I did it originally, so I can check my work as I go. And originally I did something kind of like this. So just to make these two switch, I think is going to make it look nicer. So now we're going to divide by the y minus 1 on both sides. So we're going to write this as a fraction on top of a denominator. So kind of a fraction within a fraction. But we're going to have dy over y minus 1 all over dt equals -2. So now what we can do is we can integrate both sides with respect to t. So what that would look like, right? We would have this, and then we'd slap a dt on there. Well, actually, I'm just going to do this on a new line to make it look better. So dy over y minus 1 dt, and then dt equals integral of negative 2 dt. So the reason we do this is because when you integrate, you kind of add in, you multiply by this dt here, and that'll help get rid of the dt in the denominator here. And then of course you just have to do it to this side, because if you do it to one side, you have to do it to the other to keep them being equal. But that's a nice little trick when you have something like this. I use it pretty often, I think, when you have something of the form, dy dt equals whatever, and you want to integrate. So now what we have is integral of, I'm going to rewrite this in certain ways. Well, 1 over y minus 1 dy. So now really, instead of integrating in terms of t, we're actually integrating in terms of y, because we have the dy right there. And that's going to work out a lot better because there's no t in here, there's only y. So if we were integrating in terms of t, it'd be kind of weird, right? And then this one you can do in your head pretty easily. Negative 2t. Just basic power rule. And then obviously you'd have the plus c, but I'm actually going to do the plus c when we do it on this side. You only have to do one because it's a constant. If you have a plus c on this side, then a plus c on this side, you can just say, well, we're going to subtract, c1. We're going to actually just do plus c1 minus c2, but then this is just another constant. So you can just have the 1c. That part's not super important. So for this, well, for context, we had just learned in class about the whole splitting the fraction thing. I don't know if that is an official term, but that was a pretty big hint that that's what you had to do here. And it does look like there's no easy way to integrate this without the whole, splitting the fraction thing. So what we do with that is, if you remember, we have a, because we want to split this into its factors, right? We want to split the denominator into its factors, which it's already done for us actually. So we have a over y plus b, wow, okay, b over y minus 1 equals, we're going to have 1 over y minus 1. Okay, so if you could imagine when you are, if you were going like the other way, so if you started with this and you wanted to go to here, you would probably find the common denominator, right? You'd multiply this a over y by y minus 1 over y minus 1, and then you multiply the b over y minus 1 by y over y, because you want to get these denominators into this, right? So you'd multiply the top and bottom, the numerator and the denominator, by the same thing. So we're going to kind of use similar idea here. So we're going to pretty much multiply this by y minus 1, and then multiply this by y minus 1, and then same thing here, by, and then, so now, since this denominator, and this denominator are all the same, we can actually just add the numerators and say they're equal to each other. So what we can say is a y minus 1 plus by equals 1. And we can pretty much just disregard the denominator entirely. And so we want to solve for a and b here, but a and b, it has to work for every single value of y, which means we can pretty much arbitrarily pick a value of y to make it easier for us. So one thing that we can pick is the value 1, because if we pick 1, this is going to be 0, and we're not going to have to worry about a. So if y is 1, then that, like I said, this is 0, and then b times 1 equals 1. Well, pretty clear that b has to equal 1. Well, now if we pick if we pick y equals 0, that'll get rid of this term, leaving us with just a times 0 minus 1 equals 1. So that would be a times negative 1 equals 1. So clearly a has to equal negative 1. So our thing is, and then remember, this is still on the integral. We're just rewriting the inside of the integral. I think the integrand or whatever. We're not actually integrating just yet. But we have integral of, or was it right? A, which is negative 1 over y plus b, which is 1 over y minus 1, and then dy. And remember, this still equals negative 2t, but we're going to be focusing on this left side for a little bit. So now we can just integrate these separately, right? We can do this, think about it that way. And that's a property of integrals. So we can change this to negative integral 1 over y dy, and then plus integral 1 over y minus 1 dy. And so these should be pretty easy to do at this point. That's negative natural log of y, because the derivative of natural log is 1 over y, and then plus the natural log of y minus 1. And then, like I said, we're going to add the plus c, and then equals negative 2t. So now, I think it would be helpful to use another property logarithms to combine this term and this term, because we kind of want y to just be in one term, because then it becomes easier to isolate. Because remember, the goal for this is to isolate y in terms of t, right? That's what we're trying to do here. So I'm going to switch the order of these just to make it easier, because subtraction goes to division inside the log. So I'm going to say ln of y minus 1 over y. Because remember, this divided by y is the same as subtracting the natural log of y. And then plus c equals negative 2t. So now what we can do with this is make both sides of this equation an exponent of e. So I can say e to the power of this whole side equals e to the power of this whole side. And so we can use more of our properties here. So e to the power of the natural log of this is just going to be this, right? That's pretty much the definition of logarithms. But we have this plus c here. But if you remember our properties of exponents, we can deal with that pretty easily. So what we can say is that this whole thing, right, is equal to e to the ln y minus 1 over y times e to the c. And so we can combine those to make this, natural log y minus 1 over y plus c on just the one base e, but separating them right now is going to be useful. And this is a property of exponents that you should probably know. So this, by definition, is just this, right? That's how we define natural log, and then times e to the c equals e to the negative 2t. And so now let's get the y stuff by itself. So let's divide by e to the negative c. So that will be y minus 1 over y equals e to the negative 2t. So I could say divided by e to the c, but again, properties of exponents, doing that would be the same as just subtracting c from this exponent. So I'm going to do that. And so multiply by y on both sides, y minus 1 equals y e to the negative 2t minus c, and then get the y terms by itself on one side, so y minus y e to the negative 2t minus c equals 1. Factor out the y, we're almost there, don't worry, although there's another step, I'm not going to lie to you. So that'll be 1 minus e to the negative 2t minus c equals 1. And then finally we have y by itself. We have y over 1 minus e to the negative 2t minus c. Okay, and yeah, we're done. Just kidding. We want y in terms of just t and some other stuff, but right now we have another variable here, which is this c. It's a constant, but it is still an unknown number at this point, so we need to solve for this. But we are given a piece of information. So if I scroll back up, at time t equals 0, 10% of the people have heard the rumor. So that means that at time t equals 0, y, which is the proportion, is 10%, which is 1 over 10. So we can use that to solve for c. Okay, so this is our equation, but we have to solve for c. So let's replace y with 1 over 10 and replace t with 0. So 1/10 equals 1 over 1 minus e. Well, negative 2 times t is just going to be 0 if t is 0, so we can kind of just forget about that and call it negative c. So let's multiply by, let's get rid of the denominators. 1 minus e to the negative c equals 10. Is 10. And then let's say negative e to the negative c equals 9. My handwriting is getting worse here. Maybe like I shouldn't be doing videos with this much writing. But actually, this is all we need to do. We don't actually have to solve for c itself because we can rewrite this, our equation. We can rewrite this actually as 1 over 1 plus negative e to the negative c times e to the negative 2t. Extend that fraction bar, right? Because again, property of exponents. And so if we actually solve for negative e to the negative c, that's enough. We can just substitute it right in there. And we actually have already, and it's just 9, which actually worked out pretty simple, surprisingly. So we can actually rewrite our equation as 1 over 1 plus 9 e to the negative 2t. And now we actually are done with that, with part B. So we write it up here. For part B, y equals 1 over 1 plus 9e to the negative 2t. All right, wasn't that easy? Okay, so that's part B. All right, let's just double check that we got the right thing. It wants us to find y as a function of t. We have y as a function of t. All right, so that's our answer for part B. And then at what time t is the rumor spreading the fastest? So we already know what y is when the rumor is spreading the fastest, right? That was part A, so don't get that confused. We're looking now for t when the rumor is spreading the fastest, but we know that for spreading the fastest, it's going to have to be y equals 1/2. So we can substitute that in for y and get 1/2 equals 1 over 1 plus 9e to the negative 2t. Yeah, all this, right? All this stuff that we just found, and it was really boring, and nobody really cared about it. So now we just have to solve for t, and then we are finally done with this stupid problem. So 1 plus, right, get rid of the denominators, equals 2, 9e to the negative 2t equals 1, e to the negative 2t equals 1 over 9. Yeah, natural log of both sides would be negative 2t equals the log of 1/9. And then finally divide by negative 2. So t equals negative natural log of 1/9 over 2. And so this, obviously, you'd have to plug this one into the calculator. So let me just do that. Negative natural log of 1/9 divided by, not exponent, divided by 2. And you get t is, let me just write it up here. The answer for C is that t is approximately 1.0986. I don't think we're actually given units for this, are we? Time t. Yeah, I don't know. This could be years, could be months. I don't really know, but that's our answer. So these are our answers. I would do a recap, but probably don't care. So I'll keep it short. Basically, the whole thing was just a bunch of algebra. Once you know this trick, the whole like divide by it on this, divide by the function on this side, and then integrate in terms of dt to get rid of the dt in the denominator. Once you know that trick, and then you know the separate the fraction trick, the whole thing is just a bunch of pretty annoying algebra. It's complicated, but it's very doable. So this thing is really just a couple concepts, and then just a bunch of annoying busy work. So kind of a sucky problem, but if you have any questions, feel free to ask in the comments. If you have any suggestions on how I could have made this video better, put that in the comments. If you're one of those weird bots that just puts like a timestamp in the video and then a link to some random website, put that in the comments too. I don't really care. It's still, it looks kind of cool that people are commenting on my videos. So yeah, I will see you next week. Goodbye.